So in today's class we are going to discuss about software design strategies. Okay, in our previous class what we have done about our cohesion and coupling. At that time we also have seen that how we were designing our software. At that particular class we have seen that structured design. What was structured design? We have talked about that one also. Here we will see different strategies of our software designing, right? Okay, now first one is our structured design. How we are going to do the designing in case of structured phase. Okay, so first one, what we see, conceptualization of problem into several well organized elements of solution. As first of all, what we know about software designing, that is conceptualization of the whole system, that is our requirement. We are just changing or transforming the requirements what we have into our implementation. Whatever requirement we have gathered, that we are transforming into our implementation. Okay, that is what we are doing in the designing phase. Here what we just try to get an optimal solution. As we have already discussed that the designing, what we have to do here, it is the first phase where we are working on solution domain. In the feasibility study and requirement analysis and specification, we were working on the problem domain. Now we are working on the solution domain. Obviously, now let's come to this point. Here, conceptualization of problem into several well organized elements of solution. Obviously, we are talking about solution. Now, what we used to do in our structured designing, as we have seen in our previous class, we were breaking the design. We were breaking the whole system into what? Some small subsystems, and again those subsystems into some small modules. So what they were well organized elements of solution. How we were using those elements, that is modules or elements in that modules also, what we were doing in our cohesion and coupling. So these kinds of things, these are well organized elements which we were using in the making of this structured design. Okay, now they were well organized. As we have seen in cohesion and coupling also, the elements should be well organized so that your high cohesion and low coupling thing will be satisfied. Okay, now second one, that is better understanding of the problem. As we have seen there also, that whatever problem, here we are working on what? The solution domain. Then, so when we are working on the solution domain, we have to have a better understanding of the problem. You have the requirements, you have the problem now in your hand. Now you have to have the better understanding of the problem so that you can get the better solution for your designing phase, so that you can get the better software, better and best quality software. So better understanding of the problem should be obviously there. Now third one, divide and conquer strategy. What we have seen there in structured designing also, in designing phase, what we were doing, we were breaking the problem. Here the whole system, what we were doing, we were breaking the whole system into small subsystems. Those subsystems into small modules. So we were just dividing a particular problem into different subsystems, different modules. We were conquering that. We were solving the problem of those subsystems and then again merging those things into a whole system. That will be your solution system or your solution software. So dividing and conquering those things, those from that big system to the small subsystems, and then conquering those problems, so that what happens there, if you are breaking your system into subsystems and then modules and then working on that, what will it help? It will help you in, if some error comes, if some fault comes, then it will only affect those particular modules or those particular subsystems, not your whole system, so that you can easily cope up with that particular error or any fault. So in this case, when you are dividing and conquering, this strategy, why we are taking this strategy, so that the whole system is not affected at once by any kind of fault or any kind of calamities. So here what we do, we just use this divide and conquer. Next, well organized modules. We have seen also in our cohesion coupling that we were working on modules, how the modules were working, and how, as in case of coupling, and how the elements in a particular module, how the interdependability between them. We were seeing how the modules working on the same, the elements working on same time. They were doing the same task at an instant of time. So these kind of modules, what we have to see there, that is well organized modules. Your modules should be always well organized so that they can easily, we can group them into different cohesion and coupling groups. Also, you can easily give a structured pattern to your designing phase, right? So now next, good design, that is having a high cohesion and low coupling. We have seen in coupling that no coupling is ideally perfect, but in case of cohesion, the ideal cohesion was our functional cohesion, which was the topmost cohesion in case of, that is high cohesion in case of cohesion branches. Okay, so high cohesion and low coupling is always seen for a good and better quality designing. So these are the things mainly what are the characteristics of our structured designing concept. Okay, so these points should be obviously seen in case of when you are working in the structured kind of designing strategy, right? Now we have to see the next one, that is our function oriented designing strategy. This is the second one. So let's see one by one what are the points, so that we can easily know about function oriented designing. What happens here? Same thing. Again, here we break the whole system into subsystems. Okay, comprises a smaller subsystem known as function. Same thing. It is your system, that is S1. Then you are breaking that into smaller subsystems. Suppose this one is if here what happens now, these subsystems, there we were working on subsystems and modules mainly, right? Here what happens, these subsystems, suppose 1, 2, 3, so these are mainly functions, that is F1, F2, F3. These smaller subsystems, when you are breaking the system into, these smaller subsystems are mainly known as functions, because they are doing some different kinds of tasks. There we were seeing breaking the subsystems into modules, but here your subsystems are known as smaller units that are known as function. Why? They are doing some specific work, some specific function. That's why we are calling them, these subsystems, as smaller function. Now what happens? Divides the whole system into small size functions. The whole software, your whole designing, that is your whole software, is going to do some function. Okay, now when you are breaking that whole software, we are breaking those into smaller functions. Again same thing, same concept, divide and conquer. Why? Again we have to see that every small, so that what happens, whenever you are working, you are concentrating on a particular function, you are getting a small function, a small subsystem. You are working on that so that other functions or other subsystems, they are not affected at once. Same thing is happening here also, but we are calling them function as they are doing some specific kind of work. Third, functions share info by info passing, that is how they are sharing their info. Okay, or using global data information. How they are sharing their information. So information can be shared, that is your data sharing. How they can do? First one is, that is passing parameter. Okay, passing parameters. Passing parameters means, in this case what we will see, that is the information. They are passing the information from this function to this, or from this to this. They are just passing the information from one function to another. So this is the thing, how they are interconnected. These functions are interconnected with each other. So they can, how they can share their data, they can obviously pass the parameters. In form of parameters, they are passing the data from one function to another. Or second thing, what they can do, they can share the data or use the data of the global data. We are having a global data. Suppose this is my D1 set, that is my global data. Okay, this is my global data, and these functions F1, F2, F3, anything F up to Fn, they can get the data, use the data of this global data. They all can easily share the data or get any information from this global data. So two things they can do. First thing, what they can share the data into, they can interchange the data, or they can share the data between them. Or second, what they can do, they can get the data using this global data. Global data is there which is having all kinds of data, and every function have the eligibility, or they can easily access that one. They have the authorization to access that global data, so they can easily get the information from this global data. Then now next one, data flow is shown by DFT. Now in case of this functional strategy, what we see in function oriented strategy, the main thing that we use is the DFT. How the data is flowing. We have shown you how the data is flowing from one function F1 to F2 to F3. How this is going on. Okay, so this thing is going on from this to this. This is what? This is data flow. And how we will show this data flow? By DFT, that is data flow diagram. Okay, so data flow diagram, what this do? This basically shows us the how the data is flowing from one entity to another entity. Okay, from one function to another function, how this data is going on, how this data is flowing. So this DFT we will see in another classes in descriptive manner, that how this DFT are working. The level 1 DFT is there, level 2 DFT is there, the basic DFT chart is made. So how this DFT data flow diagram is done, that will be seen another class. But here basically you can know that data is flowing, and we will show that data flow in the pictorial form, that is a DFT. Okay, now DFT shows what? How function changes data and state of system. Mainly, one more thing. Here, program, basically here what happens, the program mainly works on, here in case of function oriented design, here what happens? We have seen that one function is there, F1, one input is given here, IP, and one output is coming from this. And we have seen this basically, what is this function? Here what happens, this is my input and output. Here some processing is done. Okay, the data is processed here. Whatever data I am giving here as input, that is processed here. So what is this? This is mainly the state of my program. Now, what is the state of my program? Maybe it can be active, inactive, or anything. So it can be idle. So these things, the state of my program, this is changing when a function calls. Okay, mainly the state of the function, that is state of the program, it basically changes. But the input which you are providing to this thing, this input never changes. Since you are giving an input, you are getting an output. The input not changes, but the state of my program is changing. Mainly sometimes it's active, maybe sometimes it's idle or inactive. So these partially active. So these things are changing the state of my program. So this basically, this affects your program at a instant of time. So here in function oriented design, what happens? Our function oriented design mainly focuses on the input, and it doesn't focuses on the state of your program. Whatever is your state of the program, it doesn't affects your program, or it doesn't affects your function. It basically, what happens, it mainly focuses on the input. Then, so it's very much is a privilege, since it's not seeing the state of your program. So obviously it's a privilege for the development team. So here what happens, it is focusing on the input and not on the state of the program. This is also one point. So changes of the state of the program, if your state of the program is changing from active, idle, anything, it will not hamper your function, your designing, okay, or your working of your software. So this what happens in your function oriented. Now we were talking about DFT, okay, data flow diagram. Now what happens, what this DFT shows you? Data flow, okay. Second thing, how the function changes. Function changes. How your function is changing from this function to this function. So this function changes which function you are working upon on a particular instant of time. This thing is shown by your DFT. How your function is changing, how your working is changing. Okay, from this, mainly the flow, how the flow is going on, data flow. So this, from this function to this function, this one, that is the main thing. So this thing is shown in your by your DFT. And second thing, what it shows is the state of your system. What is the state of your system? These things are shown by your DFT, data flow diagram. We will see in next class. Now last one is system broken into smaller units, that is function. We know that the system is breaking now the system has been broken into some small subsystems. But what is happening here? How we are breaking that one? As I have already told you that since what is a function? Mainly function is what? A working, mainly a work done by something. So here what happens? On the basis of operation, what kind of operation your function is doing. So in that particular manner, on what kind of operation your function is doing, we are going to break or group those functions, or when we are breaking the system, we are going to group that on the basis of the operation, what kind of task your function is going to do. This grouping is done on the basis of that particular operation. Okay, suppose this thing, how they are working, maybe this is working on some function, this is working. So grouping is done, basically grouping is done on, or breaking is done on this thing, that is the work of the operation, on the basis of operation of the function or working of the function. Okay, you can easily break that smaller units. We are grouping those units on the basis of this particular operation. Done. Now what is happening? Each function, that is all the functions as described in, then what happens when we are grouping, we are breaking those functions, they are working, and what happens then? We are seeing that again we are merging that one. Divide and conquer, we have seen what we are dividing the function, dividing the whole system into smaller units, and then we are again, what after the working is done, the conquering is done, your problem is solved, then you are merging the whole thing. Here also same thing, we are breaking the function into some small, we are breaking the whole system into some smaller functions. That is, here it is my F1. Okay, then smaller functions we are breaking it into, and then again merging those whole piece of things into that F1 again when your work is done. Okay, so this thing is what is done in case of function oriented design. We are breaking the system into smaller subsystems, that is that smaller parts are known as function. Basically the main thing, how we are breaking this, doing this grouping, that is on the basis of their operation, what kind of functioning they are doing, what kind of working they are doing. So we are breaking on that basis of that operation. And main thing is that it is working on the input of my data, it is not working on the state of the operation. It doesn't matter whatever your state of the program is, it doesn't matter on that one. Then, and we have to see that after the whole thing is done, then each function is described in large. Every function we are describing in large. After every function, suppose 1, 2, 3, 4, so every function, now we have done what on all the functions. Now every function, suppose this one was F1, so they are described in large, and after everything we are merging those functions. This is what is happening in our function oriented design. Now we will see our third most, that is our object oriented designing strategy. These are what was the first one was structured, second one was our function oriented. Now we have to see the object oriented design. It's a typical one. Now what happens in object oriented designing? We have seen Java, that is our object oriented language. You basically have some idea on what is object oriented thing. Now here mainly in object oriented thing, they are basically something works on entities and their characteristics. Here what happens, suppose what are entities? Entities are mainly what? Suppose this is my entity, suppose we are talking about bank, a particular entity, or we are talking about student, a particular entity. That means what? A certain object. We are working on a certain object, that is our entity. So characteristic of those entities, that is our attributes, they are called attributes. Okay, these are entities and some attributes are there, entity and attributes. Okay, attributes. So these kind of things are being worked here on object oriented designing. Then so here what we have to see, we have to know about some specific terms which already we know in our object oriented programming, that is in case of Java. So here we see that this is my bank or student, whatever this thing is called by entity, that it has some attributes. Suppose if this is student, then they will have some roll number, some name, etc, etc. So these kind of things are my attributes, that is characteristics of that particular entity. Okay, now let's see what are the things, what are the basic terms which we use in case of object oriented designing. Okay, there are some basic terms which we have to see in brief manner. Okay, first one is our objects. First one is object. So what is the object? Mainly a object is an entity, which I have already told you, an entity involved. Entity involved. How we are going to work upon a particular entity, that is an object. Object is mainly an instance of a class. Okay, we will see what a class now. Now object means, suppose example we can give bank, student, okay, teacher, etc. So these are basically entities, means object. We are working upon these objects. Then so this is what is my entities are. Now these entities, what they will have, they will obviously have some attributes, that is their attributes or their characteristics. Okay, particular characteristics or maybe some qualities. Okay, that is if particular student is there, they will have some character, that is they will have some name, some roll number, some registration number, their address, their phone number, etc., date of birth, etc., etc. So those things will be their attributes, that is student, name, roll number, okay, different attributes, maybe class and address, etc. So these are what? These are our attributes. Okay, this we will work upon in case of object oriented design. Then second one is what? Second one is our class. What happens in a class? Class is the object, is the instance of class. Okay, in case of class, what we see, general description of that object. Okay, that is, as I have already shown you in attributes, general description. These are my general description of this particular object. General description of this particular object, that is we are saying that class is the instance of this object, or object is the instance of the class. Okay, so here we have seen two things. One is we are working upon object, and second we are working upon the classes. Then third one which we will be working upon, that is encapsulation. Encapsulation what? When we are working upon the attributes, okay, and methods together. When we are working upon attributes and methods together, they are then that process is known as encapsulation. We have read this all topics in Java also. And what happens here? It mainly restricts the data. Data hiding, we have already studied about data hiding. What it do, that is it restricts the data, outside data, restricts the data from outside world, that is our encapsulation. Then this is also a term related to Java, we have seen there also. And next one is inheritance. What is inheritance? Basically, if you are having any particular object or any particular class, so this class can inherit some information, or it can inherit some characteristics, some particular whatever, maybe some data that it can easily inherit from its upper classes. This is the class and these are upper classes. Suppose this is A, so this is B, C. They can inherit the data. Maybe this can inherit the data from A, B or C. This means it can take the data, it can reuse that data, as well as it can take the data and use it as a global data also. So this kind of inheritance is this kind of taking of data, that is called inheritance. Different inheritance, multi-level inheritance, single inheritance, different inheritance are there in our topic also. So basically inheritance means taking the data from our upper classes. Okay, taking data from using the data of upper classes. This is called inheritance. This also we have seen. Now polymorphism. What is polymorphism? Polymorphism, that is we are using some classes, we are mainly some methods, we are performing some we are using some methods. What methods? These methods will be having same name, but they will do some maybe the function is also they can do the same function also. So basically they have the same name and the function is also same, but vary in arguments. When we are talking about arguments, you have seen there that we are having some arguments, suppose a and b. Here we are talking about a particular function, suppose int. Okay, so ab, but here also int, there will be a, b, c. So these are what we call arguments. So this will differ in this, that is the arguments will be different. The method, in case of these methods, same name. Okay, function may be also same or different, but the arguments will be different. So this is what happens in our polymorphism. So these are the things which we work in case of object oriented designing. As these things are, you have already seen in Java also. So these things are used in case of when we are working upon object oriented designing. Basically what happens in object oriented designing, whatever previous data is there, we only work upon that data. Suppose some data is there already, previous data is with us, or some requirements are with us, we basically take that requirement or reuse that data. We are basically doing these things in case of object oriented designing. Some previous work had been done, and from that work we are taking something and we are reusing that one. This is what happens here. That is, this is solution comes from requirement or previous system. Any previous system which you have, from that previous system only you are getting those particular data. Now what happens? Objects are grouped into classes on behalf of similarity in characteristics or attributes. What we are doing, we are mainly grouping these things, grouping the classes on behalf of similarity of attributes, attributes of characteristics. These characteristics of these attributes, these similarities are being taken for the grouping purpose here. In case of function also, we have seen how we were grouping the functions together on the basis of operation. Here on the basis of characteristics of the attributes. So here we are mainly on the similarity of the attributes we are working here. Okay, and class hierarchy is there. As we are using inheritance, we will obviously see a class hierarchy. Like here, from we are taking inheritance, that is from this class. So we are inheriting from these classes, as we have seen already. So this kind of class hierarchy is followed in case of object oriented designing. Then next is relationship. We obviously, when we are talking about entities and different kinds of attributes, okay, so what we see mainly here, we use UML we use. Okay, and in case of entities, relationships, these things which we are talking, we are mainly talking about entity relationship diagram. Suppose when you are talking about a student, okay, now here suppose you have another entity, teacher. So what happens? These will have some particular relationship between each other. What relationship? What happens? Teacher, what they do? They basically teaches. So here teaching is what is the relationship between student and teacher. Now book, if it's another entity, so what is the relationship? Reading. Read is the relationship between a book and a student. So this is what is called relationship. So these kind of relationship are being worked upon in this object oriented designing. Then so what happens in this particular in all the strategies, what the common concept is, that is we are breaking the whole system into smaller system, and we are working on those smaller systems so that at a particular instant the whole system is not affected, but the strategy is different. That is, in case of structured design, we are breaking in subsystem, modules, etc. In case of function oriented design, we are breaking into subsystems which we are calling function, as it is mainly basically grouped on basis of some operations, that is some functions. And in object oriented designing, what we are working on? We are working on objects, on classes, on attributes, on relationships, etc. So these are what are the things which we use. Basically this one is used when you are working on some previously done system. When some previous system is there with you, or some requirements that had been used, those requirements are there, you can reuse the system in case of object oriented system. Then now what we will see, they are basically two kinds of designing processes what we follow. Okay, that is also our strategy. But these two kinds of things are mainly followed when you are talking about a designing phase. One is top down and second one is bottom up. These are the two designing strategies, top down designing and bottom up designing. Okay, what happens in top down, that is, suppose here from a system, in top down what we basically do, we have subsystems and we are working upon them. Okay, what we are doing, this is my subsystem and we have to work, that is we have to break it into subsystems, different subsystems. That is, this is a higher level function, and what we are doing, we are breaking that into lower level until and unless we are having the basic structure, basic level, that is our basic one. Okay, basic level we are getting, we are going on breaking this thing several times, same thing, breaking, again subsystem breaking. So from top level program we are going to the basic level, then we are going from top level to basic level. And here what happens, obviously this one is your whole system, then you are going upon breaking and you are getting the basic system, the basic component of your whole software. This is called the top down approach. Okay, in top down approach mainly what happens, the whole system is taken into a entity. This we are working as an entity. Now we are decomposing this entity into different subsystems level by level until and unless the basic thing you are getting, the basic subsystem you are getting, you are going on breaking that one. Then in bottom up approach what happens, different thing, that is, now we are going to work upon the lowest level. From bottom up lowest level we are going to decompose. Now we are just making them, joining them, and we are working until and unless we are getting the whole system, that is our higher level system, main system, the whole software. Until and unless you are getting the whole software as a one entity, here from one entity you are going on breaking that until and unless you are getting the basic component of your software. Here what happens, from this basics of, this is your basic level, this is your basic component. From these basic components, obviously many components are there, from these basic components you are going on attaching, you are going on doing the abstraction is going on high, okay, increasing level. So this thing you are going on just merging, going on merging from this to this until and unless you are getting the single entity, that is your whole system, this single entity. This is your higher level function, this is your higher level, the highest level. Same thing we are going on doing, that is we are merging. There we are decomposing, we are just breaking the system, and here what we are just going on merging the system. So this thing is going on in case of top down and bottom up approach. I think it's clear for you. Now in next class we will go with some another topic, and if you have any kind of doubt in case of this designing strategies, you can write to comment section. I will reply to your comments, and obviously if you like my channel then please like and subscribe so that I can give you more information or more informative video on this technical lessons. Okay, thank you. Okay, so today we are going to start our new chapter, that is software analysis and design tools. We have already discussed about software designing phase. What was that? In software designing phase, we were just transforming the requirement analysis, that is whatever requirements we have, to the implementation form. That is, we were having some requirements which were in human readable form. That is, human were giving us some requirements in the readable form that can be easily understood by human beings. Okay, but what we were doing, we were just transforming those readable forms to our actual coding, that is the implementation coding phase. Okay, so this transformation is done in our designing phase. We have already discussed that in our previous classes. Now today what we will do, we will discuss about different tools of this designing. When we are going to do something, we have to have some tools. Okay, so these tools which we are going to use now in the designing phase, we are going to discuss those tools one by one. So in today's class, the first tool which we are going to discuss is the DFD, that is data flow diagram. Okay, DFD means DFD, that is data flow diagram. Okay, so what is data flow diagram? As the name already suggests, that in data flow diagram, what we do generally, we have three things which we are going to study in this data flow diagram. We store in the data flow diagram, that is the input data, the output data, and the storage data. Okay, storage means whatever data is going to be stored in a particular system, and the input and output data. Okay, obviously those things. And what is going to be there? Whatever data is going to flow inside a particular system, that is in our DFD. That the whole information is being stored in this DFD pictures. This is a pictorial representation, that is graphical representation, or you can say pictorial representation of the flow of data in a particular system. Now what we will see here, we have one thing also, that is our flow chart. Now what is the difference between this flow chart and DFD? Flow chart is also showing us the flow of data, but what happens there? See, in flow chart, what happens? The flow of control in program module is being shown. In flow chart, what we show is the flow of the control, how the control is being flowing, that thing we show in our flow chart. But in DFD, what happens? DFD only shows the data in the system by various levels. When you are going to create a DFD, data flow diagram, for a particular system, suppose I have already shown here one, we will discuss it afterwards. But when you are going to start a DFD, then you have to see there are many levels of the DFD. Level 0, level 1, level 2, like this. So you have to see there that how much you are going to establish that one, how much you are going to describe that one. Level by level, first when you are starting the DFD, you are having a basic DFD. That is the basic concept what is going to be in your particular system. Then what will happen? Again to the level 1, you are going to insert some data, some special data, that is it will be describing your DFD more accurately. Okay, then in level 2, again you can make it more descriptive. So in level 1, 2, 3, that's a hierarchical process where you are going to make your DFD in such a process. Like see, here I have done a DFD that is of level 0 and level 1. So you can see in a level 1 picture, you can see that the DFD is very little one, very little data is there. But in this little data, the whole system you are going to describe, but in a very basic way, not in a very detailed way. A simple step, that this is my DFD, this is going to be my system, the whole process, this is the input, this is the output, and this is the stored data or the process which is going to be in my DFD. But here you are not going to give a whole description. Then again when you are going for the level 1, then at that time you are going to give some more description about your DFD. You are going to break that DFD into some subsystems. You are going to give some more details about your DFD. Again in the second level, you are going to describe, make a more detailed DFD. Okay, so like this we are performing the DFD in a hierarchical procedure. Okay, now so this is the difference. What is the difference in between flowchart and DFD? Flowchart, we are just showing the flow of our control, but DFD we are going to show the whole data flow. Okay, here no control or controlling that how the control is going, this kind of thing is not shown, only the data, how the data is flowing. Okay, now what are the types of DFD? There are two types, generally two types of DFD. One is logical DFD and second one is physical DFD. Okay, so what is logical DFD? Concentrates on the system process and flow of data in the system. It only basically it shows you how the flow of the data is going on. It just concentrates on the system process. What are the processes which we are going to see in this, in your particular system? What is the process? There are different processes included in our system. That processes we are going to concentrate on, and the data flow in the system. Okay, this thing is going to be in your logical DFD. But in physical DFD shows how the data flow is actually implemented in a system. That is, here we will show how the data is flowing. Here what? In logical what? Only the logic. That is my system, this is my system, this is my data, this is going to flow. How the data is flowing, how the processes are there, how the function is going on, that's all. Okay, but in physical DFD we will show how the data is going to flow. The data is going to flow, input, output, storage, okay, logical data. But here in physical DFD, you will show how this implementation is going on. The whole process has been shown in physical DFD. So this is the difference between your logical DFD and your physical DFD. Okay, now here some components are there. As I have already told you that DFD is a pictorial form, a graphical form. So whenever we are going to talk about a pictorial or graphical form, obviously some symbols are there. We have to use those symbols to show our DFD. Now in DFD there are some certain symbols which we are going to study, that we will be using when we are going to make a particular DFD. Okay, now let's see the symbols. First one is this one, that is a rectangular shape, only a rectangle. This is external entity. Now what is entity? As I have already discussed with you, that is the sources and destination here. Okay, that is entity, source and destination. Why? Since here you can see this is my passenger, this is the entity in this case. This is a railway reservation system. So in case passenger is my entity. So what is happening here? You can see that some arrows are going towards this. This is a process. Okay, railway reservation. So some arrows are going there. Some are going as output, and some are coming as input. So what happens here? Source and destination. For my particular DFD, this source and destination will be an entity. Okay. So these are mainly the source and destination. Entities are what? They are basically objects. I have already told you in previous class, you can see that video, that entities are basically, they are some objects. Okay, that is, you can say about some, if banking software, then bank, if for library management system, student, teacher, for anything. So these are the basic entities. So these entities are being shown here as external entity, as just a rectangular form. Okay. Now next is our process. What process is going to be done? What kind of process is we are discussing about here? Okay, as you can see here, railway reservation system. This is the reservation system. This is the process what is going to be in our particular information of the process. So this process has been shown by a circular shape. Only a circular shape, just a circle. In that circle you are going to write, here also in entity you are going to write here in the middle of the rectangle. Here also you are going to write in middle. That I have already shown here, that railway reservation system. This is my process, what I am going to do. Okay, so this thing is going to be inside this particular, see here you can see these are the processes, different processes. So here when you are going to describe about your process, that thing you are going to show inside a circle. This is your second symbol. Now third symbol, this is my output symbol. What is the output? What is going to be happening after I am giving the input, after the processing, what output I am going to get. That thing is shown by this kind of symbol. That is a rectangular with a broken edge like this. Okay, this is my rectangle and this is a edge, that is curved edge like this, or broken edge. This is the output symbol. Whenever you want to show any output, suppose you are telling about some RMS calculator. Okay, so you have to show the input, the processing and the output. That output you will show with this particular symbol. Okay, this is my output symbol. Now the main symbol, that is the data flow symbol. As we see this is the arrow, which is a data flow symbol. You can see here also there are some arrows going from this side to that side to this side. These are arrows mainly show that this is the basic thing of our data flow diagram, that is the arrows. What kind of connection is there between a particular entity to a process, to an entity, from a process to an entity? What kind of connection is going on? So this thing is being shown by this particular arrows. Okay, this is the flow of the data. What kind of data is flowing from here to here, here to here. So that thing is we are going to show by an arrow. So this is our fourth symbol. And fifth symbol is data stored, that is data storage. Storage is been shown by this kind of thing, two parallel lines, and here in between you have to show what kind of storage is there. Suppose in railway reservation system, so what is the storage? Storage is the data, that is your data storage, what data you are going to store. So here in this case, suppose when I am talking about railway reservation system, so this is my reservation process. What kind of storage should I have? That is my reservation storage, the data, whatever. When you are doing a reservation, what you do? You just go on taking some tickets. So when you are going to reserve a train or you are going to reserve a seat, so at that time you have to give some data, and that data is basically whatever the data you are giving, that is been stored in a storage. So that storage is shown here as this symbol, that is two parallel lines, and you have to show there what kind of storage is that. So in any case, when you are working with a DFD, you have to show this storage system by two parallel lines. In between you can write what is the storage or inside. But this is the symbol of storage, data storage, whatever data you are going to store. Okay, now after all these all things, now we have to see that how we are going to construct a DFD. Okay, so this is what is my DFD here, that is my railway reservation system. So I have already told you that in railway reservation system what happens. We have to show two, I am showing here two kinds of DFD, that is my level 0 and level 1. So what happens in a railway reservation system? There are two parties, that is one is your passenger and second is your admin. When the passenger, what they do, they basically they can reserve a seat, they can cancel a seat, or they can inquiry. Okay, and the admin, they will respectively whatever the customer needs or the passenger needs, they will respond to that particular query. So this is my level 0 DFD for a railway reservation system. What is there? First of all, what we have seen, external entity. So here two entities are there. This is my passenger and this is my admin. These are the two basic entities of my railway reservation system. Okay. Now what is going on in a railway reservation? This is my process, that is railway reservation system. This is my process, this process. What process? The reservation system is going to be shown, how the railway is working. So this is my reservation system which I am showing here. This is my process here in this case. So now what is happening? Now I have to show the flow of my data. Whatever data is going to be flowing in between this. Okay. So here what is the data going on? Here we can see that is cancellation. First one is cancellation. So the passenger is doing any cancellation to this process. So this data is flowing. Since the passenger is doing this to this process, so he is just the arrow is going from passenger to reservation system. Okay, that is the data is flowing from this entity to the process of reservation. That is cancellation of ticket. Second is reservation of ticket. In case of reservation of ticket, again what is happening? The passenger is only doing that one. So the data is again flowing from the passenger to the reservation system. That is your process, entity to process. But when the thing is done, if some info is given, that is after you have reserved or after you have cancelled your ticket, what happens? Some information is given to you. That information is given by the process, that is it is processing, and that is you are getting from the reservation system. This is the information, that is the ticket information which is given to the passenger. So here we can see the arrowhead is from this process to the entity. Clear? So this is what is happening here, that is from the process to entity the arrowhead is coming, that is the data is flowing. Again in here what we are seeing, when the passengers is asking for any info, suppose reservation or cancellation whatever, so admin is giving the train information. So this train information is going from the admin to the process. That is the railway reservation system is having the whatever information that is given by the admin. The admin is giving the report that whatever the train info is, up down train whatever is coming, that information he is putting in the inside this railway reservation system. So this is my process. Obviously then again from entity to process it is coming, the data is flowing. Next, where whatever reservation or cancellation, whatever data is being processed, that is the passenger is giving the data to the process, and now from this reservation system this particular data is being got by this admin. So the arrowhead is going there. And of course, whatever reservation and cancellation is there, of course the passenger info is also going from the process. The admin is getting these from the railway reservation system. So here we can see a small data about what is happening in my railway reservation system in the level 0 DFT, a particular basic idea. Then how the data is flowing from entity to process and from process to entity. But now what we have to show in the level 1, we have to just enlarge that one. Okay, we have to describe, make it more descriptive. So when we are making it more descriptive, in that case we will show the level 1 DFT. Again, what thing? This is my passenger. Now I have to show how this is going on. So my passenger is here entity in this case. Okay, now what is happening? Passenger is working on two particular processes. First process is reservation process and second one is enquiry process. Two things a passenger can do. What they can do? Either they can have the reservation system done, that is they can either reserve a ticket, they can cancel a ticket. So he is working with the reservation system. That is a particular process. Second, he can work he can ask for something. That is the enquiry. So that is also another process. Both are different processes here. So here you can see two arrowheads. One is going from the passenger to the reservation process. Again, second one is coming to the enquiry process. Okay. Now what is happening? When the passenger is asking for some enquiry, in this case, so how this enquiry is being fulfilled? So obviously the data, what enquiry they will ask for? They are reserving their ticket, they are having their cancellation or whatever ticket they are reserving. So that data he is having with him, but he can ask about the up and down train details. So here two things are there. One is the down storage and one is the up storage. This is the sign of storage. Why down and up? This is for down train and this is for up train. So these are the storage which is happening here. Okay, that is shown here in down storage and up storage. Then, so this is the database, that is the storage of down train data and up train data. Again here what is happening? Reservation process. So reservation process, what they are going to do? Either they are reserving the ticket or they are cancelling the ticket. So this particular information is there in the reservation storage. That is another storage system. This database is containing the data about your reservation, that is here, the cancellation ticket and the reservation data, cancellation or reservation data, that is here in between this. So what we are seeing here, this particular thing is broken here into ticket info, it is another process, and reservation is another process. So we are breaking this thing again into some descriptive manner. As soon as you are going from one DFT to another, you will see some more information are being inculcated in that thing. Okay, that is you are going to make some more information you are going to give there. So here we are seeing that we are giving some more information here like this. We are breaking that into a subsystem. Again this thing is broken. Again what we are doing, we are generating a ticket. When reservation process, what you can do, either you can generate a ticket, that is you are reserving any seat, or you can cancellation whatever, and either you can report the admin. If some mistake is there, some error is coming, then you can report the admin. Okay, so this kind of thing, when we are breaking this DFD, particular zero level DFD, so we are getting this kind of figure. And if enquiry, then obviously enquiry will be given from this particular database, that is up and down. So this is my level 1 DFD. Again, if you want to break this DFD in some more descriptive manner, you can easily break. You can again make this, you can give the passenger, you can break this reservation process in ticket generating process, that you can also break in different levels. So this breaking of this level particular thing, that is in a, why we are using this DFD, it's very easy to understand. You can easily, from this pictorial view, you can easily understand. If any system, when you are talking about any system and you're giving that information of myself, this is my system, so and so input I am giving, so and so output I am getting, this is the processing, it is not clear. But when you are giving this kind of structural data or this kind of pictorial data, obviously the data is very much understandable, as well as it is very clear for the person who is going to understand your design. Then And one more thing is what? It is a very structured manner. It is done in a hierarchical manner, and very structured manner is going to be done here. So it is very easy. Third thing is that whenever doing, okay, let's write those things. Okay, what are the advantages of this DFT? Why we are using this DFT? Okay, so then it will be very easy to understand, so that you can jot down also. Now let's see what are the different advantages of this DFT. Why we use this data flow diagram? So advantages. First one is easily understandable. Easily understandable. You can easily understand this by the pictorial data. Okay. Second one is what? Second is hierarchy form. So this is the hierarchy form. So it is very easy to show the level by level. You can show the data flow very easily. Okay, it is giving you the information of data flow, not only data flow, your input data, output data, as well as the data storage. You are getting every information from this DFT. You can see that every information is being given here. Okay, now also one thing is there, as we have already discussed, that this, what is happening here, high level function, okay, high level function is being again broken down, breaks into subsystems, so that it is very easily to work with. Here is the high level function, that is passenger and wind. Now we are breaking that one, that is, it has been broken down into different subsystems. Here only one process is there. Here how many processes? 4 processes are there. Again you can break that one. So what is happening here? High level function is been broken down into different subsystems, small subsystem. As we have already seen that in a divide and conquer procedure, we are going to do this designing. It will be very easy for us, so that if any fault comes, if any error comes, this is also an advantage. That is, if for any error or fault, it is easy to find. You can easily find and correct, not or correct, and correct. Okay, that you can very easily find the error. If any kind of error is there in your DFT, so you can very easily find that error from this particular pictorial data. You can very easily find if some data is there, that is, if some error is there in your reservation process, then you can correct that data, you can correct that information. If anything is there, if how much, whenever you are going to just make this DFT, you are just processing level by level. So it will be very easy, the how much your level is going to be there, how much level you are going to break this DFT. Okay, that will be very easy. That much easy will be to find any error. Since you are making some subsystems, as we have already seen in cohesion coupling, what was there? When we are breaking the particular system into different subsystems, how much you are going to break that one, that much easy will be for you to just correct, find the errors and correct it. And it will be very easy, since your whole system is not affected. This is my whole system. This is my whole system of DFT. Then, but what is happening here? I am working with this particular function. That is this is my railway reservation system. But if I want to correct anything, any error is coming, if I want to correct that one, the whole system will be affected at that time, at a particular time. But when I am breaking that one, if something is incorrect in this reservation process, I can easily correct that one, I can easily find. And again, if I am going to break that one, that will again be very easy for me to correct anything, correct the data. It will be very easier for me. So how much, that depends upon you, that how much you are going to break your DFT, how much, up to how much level you are going to get this DFT. Generally we work up to level 2 or level 1 or level 2, but maybe some more levels can be added there, so that you can have a more clear vision of your software, clear as well as more specific vision of your software. As much you are going to break your DFT, that certainty that the more and more implementation, more and more details are going to be implemented to your DFD. Since you are breaking the data, breaking the DFD, so obviously some more information, some basic, we are working with the basic information here, but you can see that here the basic information is been enlarged and you are giving some more info, some descriptive manner. Okay, so these things are going to be in your particular DFD, data flow diagram, and these are our advantages. That is easily understandable. I can easily understand the particular DFD. It is in a pictorial form, easily understandable. Second, hierarchy form, that is we are having some hierarchy, that is upper standard here, some passengers are there, some entity is there, some data flow is there. So it is in a hierarchical form, and data flow, input, output, data storage, everything is there. In a flow chart, what happens? Only the flow of data can be shown, but here everything is there. Your entity is there, your process is here, your data flow is here, your data storage is here. So everything you are getting inside a particular figure. Right, and what happens? The high level function is being broken up into subsystems, basic subsystems. So up to your breaking the subsystem, obviously you are getting more and more details of your system. Then, and what is happening here? If error and fault they are occurring in case of any particular process, then you can easily find that error or fault and you can easily handle that one. Clear? So this is what is happening with our DFD, data flow diagram. Now next topic is about data dictionary. Okay, now let's see what is data dictionary. Data dictionary is basically what we know from dictionary, word dictionary, that is we are finding about some data, right? So today only we will discuss about some basic information, we will not go for further description. In next class we will describe that one. Okay, so what is data dictionary? It is basically data about data is being stored there. Okay, so let's see. Data dictionary. Basically what happens? Data about data is given here, stored here. Okay, here what happens? List all the items that is appearing in your DFD. What items? Suppose what items are there? First one is our input data, output data, data flow, again data storage. So these things. So the list of these things are being in here. So DFD, list of things in DFD, that is list of components in DFD. Okay, whatever there is present in our DFD, that things we are going to list, sort down those things in our data dictionary. Then data items, that is how the data is, we are going to store the data, that is flow and storage. That data items which we are going to show the flow and storage, that is data items being stored. Okay, data items which are flowing in this in DFD. Okay, that is data flow. That is your data flow. What data is going to flow? That is also included in this DFD. And the purpose of this is the things, that is the definition. What definition are there? Definition of your data. What is the definition of data? Let's have an example. Suppose only a singular data we are not working upon. Then, so what happens? Suppose I am having a gross pay. So in case of gross pay, what will be my, basically it is broken into two components. That is mainly what happens in a gross pay, that is the regular pay and overtime. That is my regular pay, that is I am getting whatever pay, and my overtime pay. So this is what is there in my gross pay. So what you can see here, that this is not a particular data. Here it is a composition of two data, that is my regular pay and overtime pay. Done. So these particular components which we are going to use as a composite data, that data about these composite data, that is our composite data. Composite data. So data about this composite data is also going to be included in our data dictionary. When we are talking about data dictionary, I have already told you that is data about your data. In dictionary, what we find? We are taking a particular word and we are getting the data about that word. But in data dictionary, what is happening? Data about your data. That is being included here. So here what we are finding here, that is composite data. That is, if I am having the gross pay, that is composition of two things. That is my regular pay and overtime pay. Got it? Then this regular pay and overtime pay, what is the connection between these? So these are being composing to get the gross pay. So this is not a singular data. This is a composite data. In this case, the data about that composite data is also being given in this data dictionary. So basically the data dictionary is having every data about your DFT. Every singular data, every minute data about your DFT, that is being included in this particular data dictionary. Then there are also some symbols which we use in data dictionary. So let's see what are the symbols. Basically these symbols are used when writing a data dictionary. Okay, we will see in next class how we are going to write the data dictionary. But in today's class, let's see what are the basic symbols used in this data dictionary. Symbols of DD, that is data dictionary. So first symbol is plus. Plus is composition or addition. So addition means when we are adding the data, suppose A plus B. So these are my two processes. If I am adding the data of this A and B, so that is, this sign will generate this, that is my, I am adding the data of A as well as B. So this is what is happening in this kind of sign is being used to show the addition or composition of two data. Now second one is this one, that is two comma signs. This is what? Either A or B. So this is being shown like this, A or B. Either this one or that one. Then third one is this kind of bracket. If I write like this, A plus, suppose this B, A plus B, then here what is going to be there? That is either A or A plus B. Then either A, only singular A, or after bracket what is there, include the whole thing, A plus B. This has been shown by this particular bracket. This is our third symbol. Fourth symbol is what? Second bracket. What is this symbol generates? That is iteration. Iteration of data. How we will show this iteration? Suppose I am writing here some name. Okay. And I am writing here 5. Then what will happen? Obviously, this name will be generated 5 times. This is the thing, that is iteration. This bracket is given for the particular thing which you want to iterate, and the basic number which you are going to, how much time you are going, how many times you are going to do that iteration, that is written outside the second bracket, that is 5. That means I am going to repeat my name, or I am going to repeat this name 5 times. That is name, 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 name 5 times. Okay. So this is case of iteration. Last one is one more, that is equals to. Equals to is for equivalence, that is A equals B, that is equivalence. To to show the equivalence of two data, that is data of A and B, they are equivalent. You have to show by this sign, that is equals to, very basic sign. And the sixth sign, as we have seen in many programming languages including C, this one. This is a very known sign. What is this sign for? Comment. This is for comment. For any comment section you can give this sign. So these are the basic signs which we are going to use when we are going to make a data dictionary, right? What the data dictionary contains? It contains about all the list of all data, everything from A to Z, everything which is in your DFT, but in a manner, in a structured manner. As we have already discussed, everything here will be in a structured manner, so that why we are doing this? Your designing phase is going to be the output for the implementation phase, okay, the coding people who are going to code. So obviously you have to write it in a structured way. So these symbols we will be using in next class to show how the data dictionary is going to be generated, how we are going to write with the help of a DFD. First we will have a DFD. From that DFD we will generate a data dictionary. That we will do in our next class, okay. Till then, if you have any queries regarding this DFD in today's class, if you have any queries, any comments, anything, then you write to my comment section. I will give you the reply. And if you like my channel, then please give a like and subscribe the channel so that we can discuss about more topics, okay. Till then, goodbye and take care. Okay, so in today's class we are going to continue what we have studied in our previous class, that was data dictionary. So what we knew about data dictionary? All the components which we used in our DFD, that is data flow diagram, that components as well as all the data about those data which were in our DFD, that were included in the data dictionary. Then now we know that data dictionary contains all the data about DFD. Now how to write that data dictionary? Before that we have to see a particular DFD. We have the DFD for a tic-tac-toe game, and in which we have two levels of our DFD, that is 0 and 1, okay. So one more thing, 0 level DFD is known as context diagram, okay. This was missed in last class, that is context diagram. We will see that in context diagram what happens. Suppose this is our 0 level diagram, okay, that is 0 level. So what happens in this context diagram, that is here in only one circle everything is included. That is, there are some many things which you have to consider. That is, first one is in one circle only, that is in one your particular bubble, this is called bubble, this bubble, you will have the name of your software, what your software is going to do. That is basically written in your this DFD, okay. That is context diagram, 0 level DFD. This is our 0 level DFD. Second thing, this 0 level DFD will never contain more than one bubble. Only one bubble will be there, which will include the whole subject, whole software, what is there in your whole software, that is included in this 0 level diagram DFD. That is your context diagram, okay. What is this known as? This is known as context diagram. That is your 0 level DFD, level 0 DFD, okay. This is also known as context diagram. Here what we can see, only one bubble will contain the whole data about your particular DFD, about your particular software, okay. What your software is going to do, that will be included in that DFD, 0 level DFD. And that particular bubble, only one bubble will be there in your 0 level, that is your context diagram, not more than one bubble. Many people, what they do the mistake of making more than one bubble in the 0 level DFD. Here only your basic idea will be there, what is my software and what it's going to do, that's enough, nothing else. Here we have shown that one, that is only the one DFD, that one bubble, that is showing me that this is my tic-tac-toe software, okay. Here what I am seeing, here human player is playing, okay, with this game. So what the main thing is happening, that is the human player is playing one move, that is, this is my entity, as we have already studied in our previous class. You can see the video. There what we have seen, this is my human player, that is my entity, external entity. What it is doing, it is playing the move. That is going to my software, that is my tic-tac-toe software. Then what is happening? This particular software, it is displaying that particular move in your board. You are having a board, your game board. As we know that game of tic-tac-toe, what happens there? This kind of thing is there. Okay. So what is happening when the player is playing a move, that is, it is making a cross or a circle, the tick that is going to the software, and the software what it is doing, it is displaying that in your board. Then, so this thing is happening, basically what thing is, this thing is happening in your tic-tac-toe software. So here in our basic level DFD, that is our 0 level DFD, we are showing that much thing, that is, this is my software and this is my entity. So this entity is moving, it's playing a move, and the particular software is showing it's displaying the particular move to my board. This is my board which I am seeing here. This is my particular board. Okay. So this is what is happening there in the diagram, context diagram. Then here only one bubble will be there, not more than one bubble, and this basically this bubble will have the basic function what your software is going to do. Clear? Now in our second diagram, that is my level 1 DFD, what is happening? Now we are breaking that DFD into some more function. What is happening now? Here we are seeing there are 4 basic functions, that is our 4 particular bubbles are there. Okay. Now what is happening? This is our display board, that is this board. What is this one? This is our data storage. Okay, data storage, where we are storing the data in this particular board. This is my board. Okay, so in this board what is happening, you can see how many boxes are there? 9 boxes are there. So 9 kind of input can be there in my tic-tac-toe board. Then here what is happening? Displaying the board. First function you can see here, this one, when we have to number our DFD. Always whenever you are making a DFD, you have to number your DFD. How? In the first level, there is only one bubble, no more bubbles. So what I have to do, I have to put a 0. This is my only one function, that is my tic-tac-toe software. So I am putting a 0. Since it is my, in every function you will be putting a 0 there. Why? This is your basic DFD. Then every function, whatever you are going to make, you have to put a 0 for your 0 level. Now what you are going to do, here you are making 0.1, 0.2, 3 and 4. These are the main DFDs which are coming out of this 0. That is my basic software, tic-tac-toe software. What it is doing, displaying the board. First thing what is happening, that is, it is displaying the board to all the players. That is happening here in my first function. I am seeing a board where nothing is placed, only a back-end board of tic-tac-toe board. Then, now what is happening? So, how I am getting that board? How I am getting that, displaying that board? How I am getting that one? I am getting that one from this storage. This is my storage, and from storage, a function you can see an arrow is going. That is my data is flowing. That is displaying the board. Okay, so what it is doing? It is displaying me the particular board. Then, now what happens? Here the player is making a move. Here the player is making a move. The data is flowing. That is from the player. It is making a move. What is happening? This particular function will validate the move. That is what kind of validity? See, suppose it is a backend one empty board is there. So if I am putting any sign, suppose cross or circle, if I am putting it in anywhere, I can easily put that one. It is validated. But if suppose here some sign is there, here some sign is there, here some sign. If the player wants to put the sign here, of course, this particular function will not validate that one. Why? Since already this is been, it is not empty. It is been placed by something, that is either cross or circle. So it will make it a non-validated one. It is invalid, that one. Okay, the move will be not validated. So this will happen for this particular function. And if the place is empty, then obviously it will validate the move and the player will play that one. So this validity, what it is going to do, this validity will be, the data will be flowing to the board. Here the board is being shown by this display board, and here the validating the move will be given to the board. Then what is my third function? Playing the move. If the particular move is validated, then what will it do? It will play that move. Suppose I am playing for this particular person, I am playing a circle. Okay, then I am validated since it's empty, so it will play my move here. Then, so this is also what it is doing. It's playing the particular move to, it is storing the data to my board. It is playing the data, or it's playing my move to the board. Okay, so again the data is flowing from here to here. Then now what is happening? After this whole thing is going on, the whole thing is done, and the whole particular game is completed. Then what will happen? A particular winner will be there. Okay, so when the winner will be there, what this board will do? This board will flow that data to this particular function. Here what is written there? Check winner. This function will check whether it's the winner is correct or not. Whether the move validated by this particular function, it is the winner is correct or not. If it is correct, it will show the result. Okay, it will show the result. Otherwise, what it will do? Obviously, it will again it will show the result. Or if the result is not correct, sorry, if the result is not correct, that the winner is not correct, then it will again do the same thing. Okay, same circle will be done. And if the winner is correct, that is yes, it's the winner, then it will show you the result. Then, so this is what is happening basically in my tic-tac-toe software. Okay, so this is my level 0 and level 1. Now what I have to do, from this software, I have to make my data dictionary. How I will make that one? We have the symbols already read in our previous class. So now what we will do, we have to write every particular thing, whatever thing is there in my particular this data. So I have to show that thing here. Okay, so what thing I have to show? First of all, this is my move. Okay, move is what? It is my function. So we know that in basically what happens here, this is my, these particular things are my data flow. So in DFT, the main thing is what? The main thing is data flow. So that thing you have to show. So first one we will see about the move. Okay, so what the move? Move is what? We have to show that what is going to happen in the move. That is, it will be an integer value. Why integer value? Since you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are these? These are integer values. So I am playing here for my integer values. I am giving the integer values only. So here we will write what? Move. For the move function or the move data, what is flowing here, integer is the value data type which I am using, and comment will be what? Number between 1 and 9. From these 1 to 9 boxes, I can place my data in any of the particular box. Then, so this is what? This is the first one, that is for the move one. Or here also, moves, we are playing for the move, so this move is going to be described here in my data dictionary. First one is done. Now we will go for the further one, that is display. Now what is display? Here you have seen move, done. Now display. What is display? Display is game plus result. This plus we have already studied in our previous class. This was the symbol of comment, and this was the symbol of what? Addition or composition. We are going to compose these two things. Add these two things. What thing the display will show? First thing, it will show me the board, that is the whatever move we are going to do, that is our game. Basically what game is going to be there, and last it will show me the result. So result and game are both the things which my particular software is going to show in case of display data flow. Whenever we are playing for the display one, we will be shown this one, the game and result. So second one is also done. We have used this plus symbol also. Now for the third one, that is my board. what my board is. Okay, now game, what is my game showing here? In case of game, I have used this game. So what my game is showing, okay, what the game, particular game function is showing, what it is showing me, the board, particular this board, that is my data storage. Okay, so this data storage is being shown by this game. In case of game, whole game is shown where? Here in this data storage, that is my board. Okay, so this case we are showing our data storage, whatever thing is being stored in our particular board. Okay, now in case of this fourth one, that is board. Now we have used board. Now what is board? You can see here that everything is going on one by one. First we used move, then display for this one. Now after display, what? Here game. So what is game? We have used game. So game, we are showing game, that is board. From where we are getting the game? We are getting the game from the board. Then again board. Now what is board? Board is what? In previous class, again you can see what we have discussed. Iteration function. What was that iteration function? Like this, that is integer value. What integer value I am going to repeat? That is 9 times I am going to repeat that one. I am going to repeat this board 9 times. What board? Why 9 times? After 9 times you are not going to have any empty space. Maybe a game of tic-tac-toe, maybe you can get the winner in 5 attempts, or it may be the last attempt can be 9 attempts. That will be showing any a draw game which will have no winner. So maximum you can have 9 attempts. So that case, what? Integer value in board game, what we are getting? Integer value, that is 9. The iteration will be for 9. 9 times we are getting a value, that will be an integer value obviously. So 9 times we are going to iterate that one. If you are getting the winner before 9 times, you can get that one. It's okay. But if you are not going to get, maximum you can have at least 9 values. So we can iterate up to 9 values. So we have used a iteration function also, that we have seen in our previous class. Then now what? Here we have seen result. Everything is clear now. Move is clear, display is clear, game is there, your game is described, your board is described. Now the last one, that is my result. What is my result? There also we have seen either this or this. Either this or this function we have used in our previous class. You can see the sign. Now what can happen here? In this case, what can happen? You are playing with the computer, right? So first, suppose you are giving a particular sign, computer is again giving a sign. This all happens in a tic-tac-toe software. So now here there can be 3 possibilities which can be given as a result. What possibilities? First one, computer won. If you lose, then computer can win. Second one, human won. That is, if computer loses, then you can win. And third one is what? A draw game. So these are the basically 3 possibilities which can happen in a tic-tac-toe game. So here what we can see, either this or this one. That function we have already studied in case of data dictionary symbols. So this symbol also we have used. Since it is a written statement, so we are giving this inverted comma sign. So computer won, human won, or draw. So basically what you see in this particular data dictionary, what you can see, everything, every DFD, whatever data flowing is going on in your DFD, everything, each and everything you have to describe in your DFD. First take one function from a level 0, go continuing from that one, you are getting again a word, again search that one, give the basic data of that function, again the next one, data storage, everything, data storage, the whatever data flow is going on, your entity, everything should be included in your particular data dictionary. Here also you can see my move is there, my display is there, my particular game board is there, game is there, whatever game is going on, that is there, and my result is also there. Here the result is also there. So everything will be, whatever thing we have used here, each and everything will be included in your data dictionary. You have to see that none of the thing is being skipped. Everything will be in your data dictionary. Why we are making this data dictionary? If anyone from the testing, that is your implementation team, is going to see your data dictionary, then they can easily have the idea, basic idea of what is going to happen in your particular software. So this is what is happening. As we have already discussed, data about data, that is the metadata. Every data about the data is there present in your DFD. That is your data dictionary. So you can see here all the things we have included in basic, this whole structure, the pictorial structure, whatever thing you have made in your DFD, whole diagram, whole thing is being given as the small document, that is your data dictionary. Very small, but everything is maintained there. You are making the whole DFD, but in a basic, in a very short thing, you are making the whole data dictionary, and the whole thing is covered there. Right? Now, what we will see, what is the importance of this data dictionary? Why we are using this data dictionary? Everything has some importance. We have some importance here. Let's see now. What is the importance of this DFD, data dictionary? Okay, let's see that one. And we have to also see that, so we have to start a data dictionary whenever you are using. Start from the basic function, that is your basic DFD context diagram. Then you go to above functions, that are your secondary functions which you are using in your level 1, level 2, etc, etc. Okay, so that you will go of it automatically it will come from first. When you are taking a function, automatically when you are describing the function, you will again get the next function. This is going on until and unless you will be in your ultimate level, the last level. This will automatically come. You will see that automatically you are getting the functions one by one. Then now, what is the importance of this data dictionary? Okay, importance of data dictionary. Okay, now what is the importance of data dictionary? Why we are using this data dictionary? Why? Since we can use here an standard terminology. Okay, terminology. Why? Many people are working in your team. When in your designing team, so many kind of people are working. In your implementation team also some people are working. Some standard terminology should be used. That is, we have seen what kind of symbols we are using. So in every DFD or every data dictionary, these kind of things will be used. So it is basic and it is very much known to everyone. This is your standard terminology. It's not going to change in any way. Whichever company you are going, whichever data dictionary you are going to see, you will see that these terminologies are not going to change. They are always the same. Okay, since this will help us. If these terminologies are changed, then again this company's DFD or this company's data dictionary, you have to see what are the terminologies again in next company. That is not happening. Whichever team, whatever team is getting the data dictionary of any company, they can easily work on that. That is the terminology is mainly standard. They are not changed anytime. Whatever context, whatever symbols, whatever you are using, they are not changing with time. Not with time or not with company. Never changing. They are same always. Why this is happening? Why we do that one? Why we are using a standard terminology? This advantage is what? For every engineer, okay, every engineer can easily understand this, can easily understand, okay, these things. They can easily understand. Whatever, wherever, all kinds of, whoever coming to your team, whoever is going from your team, doesn't matter. Your work will be going on. Since everyone is friendly with this kind of symbols. Okay, everyone knows that one. Whoever is working in your designing team, if new people are also coming, they will also know this kind of terminologies or this kind of symbols. They are, since they are standard, so they are not going to change. So whatever your team is going to change, if your team is changing or maybe if anything changes, then that for that particular engineer also, it is not going to be an unknown thing. Okay, they are also knowing the same thing. The work will not stop at any point. This is the main thing what is happening here. Third thing is what? It is containing all the definitions of your DFD. all the definitions of your DFD is being contained here. So if your DFD is, whenever you are anybody is seeing your DFD, they can easily understand your data dictionary. All the details of your DFD, if by pictorial view they are not getting anything, they can easily see your data dictionary and they can easily understand what is going on in your DFD. Maybe pictorial, whatever things you have made, maybe the person is not understanding that one, but when he is seeing your data dictionary, they can easily understand what is going on in your DFD or what thing is going on in your particular software. Okay, these are the things which are the importance of your DFD. And again, what, since these things are going on for your DFD, all the SRS, whatever things are there in your SRS document, they are also contained here. All the functions in your SRS document are also contained in your particular DFD data dictionary. So you are getting the whole things. That requirement is also there in your particular data dictionary. The designing thing is also there in. So it's the full package. Okay. So this one is having a very important role in your software engineering designing. Then now what we will see, what are the errors, what kind of errors can be there. So basically, since when we are making a data dictionary, some errors are there which everyone makes, but you have to take care of those kind of error. Okay, before that we will see what I have told you, one thing, that is my context diagram. We will see the errors afterwards. Okay, context diagram, one thing you have to see there, that is your level 0. Okay, zero level DFD, you have to see many things. Suppose we are taking the example here, suppose user is there. Okay, next here RMS, mean I am doing for a particular calculator. Okay, RMS calculator. So what is it's doing, the user is giving the data, it is calculating the RMS and it's giving to the user back. So what is happening, basically this is my calculator which is showing the RMS, so root mean square. So this thing is again shown to the so what is the main thing, this is my software, this is the main function. I cannot give more than things in this particular DFD, context level diagram, that is my level 0. Every time what mistakes everyone makes, that is this kind of thing is having this, they are making what, they are giving more than one bubbles in this particular level 0. This is not happening. Whenever you are going for a level 0, you have to see basically what is there only one bubble will be there, that is the whole function of your software, that you have to show with a single bubble, not more than one bubble. Okay, that is what is happening in the context level diagram, that is your 0 level diagram. You have to take care of that one. Second thing, you have to see that whatever thing is going on, okay, that is this data and this data, you have to see the data flow. Every time you have to show the data flow with the arrowheads, where the arrowheads are going, that also you have to see in your context diagram. Okay, now what we have to see, while constructing a DFD, this is what is happening in your context diagram. So these are the basic things which you have to see in your level 0 diagram, that is context. One bubble will be there, not more than one bubble, and the arrowheads, you have to see how the function in a very basic way, you have to show the basic function, that is my software is going to do this basic function. So very means very smaller way, and very not in a very huge way you have to show, no, very basic thing you have to, the main idea you have to give by this context diagram. So with only one bubble. Now let's see what are the errors while making a particular DFD. When you are making a DFD data flow diagram, basically what are the errors which happens, what are the errors which are mainly done by any people. Okay, first thing is that context diagram contains only one bubble, as I have already shown you, that is this is my RMS, this is my particular person, that is the user, and this thing. So this thing is happening RMS, so this is the thing what is he is giving the data and it is returning the RMS. So only one particular bubble will be there. What everyone do, they makes a mistake that they are giving 2-3 bubbles, that no, I am not satisfied with one bubble. Whatever function my software is going to do, that cannot be described in one bubble only. I am going to do 2-3 bubbles. I am going to show 2-3 functions so that I can easily show it more accurately. But no, you have to show your DFD, context diagram DFD, that is level 0, with only one bubble. Basic function, you just show how the basic function is going to, what the user is going to give you, the input, and what output you are going to, basic function, nothing else. Okay, so this is the one error but everyone do. Okay, this one. Then second one is what? External entities, that is my user. These external entities are basically used in this kind of DFD, that is my level 1 DFD, it is level 0 DFD. Whatever entities you are going to use, those entities are basically used in this context diagram only. That is your external entity. External entity, okay, that will be used only in this 0 level, not in other levels. Basically, you are using that in your 0 level. Why? There, what you are going to show, you are going to show how your DFD is going to, how your software is going to work. So there you need a external entity to show the function of your DFD. So you are using that particular entity in your 0 level, where you are showing the function of your software. Now what? Third one, so in other levels, level 1, 2, how many levels you are going to make, you are not going to show those external entities. Now what? Third one is up to 3 to 7 bubbles. You can make up to 3 to 7 bubbles for a particular bubble. Whichever level is there, you can make minimum 3, maximum 7 bubbles for a particular bubble in your DFD. If I am making a DFD, I am making a bubble that is showing my function. Now, when sub functions you are showing, whatever things are going on, that thing you will also denote with the bubbles. But for a particular bubble, since this is my bubble RMS, what we have seen in the previous one, that is my tic-tac-toe software was there. Tic-tac-toe software was there. This was my bubble. That was my 0 level bubble. I am showing it like that. But from that, what we have seen, we were making 4 bubbles. Validating the move, then displaying the board, displaying the checking the winner, and what was there? Checking the winner and displaying the board and playing the move. Okay, so these things were there. So I was breaking my bubble, particular bubble, into 4 other bubbles, but not more than 7. You can make it up to 7. If you want to make more and more describing nature, you are making it of more describing nature, then you can give up to 7, but not more than 7. Again, what? Not less than 3. Up to 3 you have to make. Up to 3 bubbles, that is, it will be showing up to 3 sub functions will be there, which will be showing the function of your particular bubble. That is a particular function. Okay, this will be my, you see, tic-tac-toe was my basic function. It was my function. So I was having 4 sub functions. That was validating the move, the displaying the board, playing the move, and showing the winner. Okay, so these were my sub functions. So I can make the, I was making it 4 sub functions. You can make it more than that one also. You can describe more. If you want to describe more, you can do that one also. Again, in level 2 also, same thing. Whenever you are taking a particular function, you can make 3 to 7 bubbles, not more than that, in any level, whatever level. We are making, what we are doing, we are, first of all, we are having the basic function, that is, it was the basic function, what, tic-tac-toe. Then from that basic function, we were breaking that one. So again, this is also my function. Now in this case, when I will be making level 2 DFD, this will be also my function. From this also, when I will break it, I can break up to 3 to 7. Okay, again, next function also you can break like that. Level by level, you are going ultimate level. Up to when you are reaching the ultimate level, you will see that every bubble, every function can have up to 3 to 7 sub functions, not more than that. Then, so this also, it also happens when, while making an error, this can also happen. Maybe, okay, I am satisfied with 2, I am not going for 3. No, you have to see this one. 3 to 7 you have to maintain that one. That is the basic thing. Now what happens? Control information. Control info should be there. Okay, control information should be there. What control information should be there? This is my control information. Whatever thing, that is how my data is flowing. Control information means what? Not the whole thing. I will not show. It's not a control flow chart. It's not a flow chart that I am showing the control flow. How the flow is, how the control is being flown in the chart. No. Here what? The data control. How my data flow is going on. That thing is shown here. Okay. How my data is flowing. From there, always see the head of the arrow. You have to see that one. Since it's a data flow diagram, always you have to take care of how the data is flowing. Done. So always take care of the arrows, your arrowheads, how they are going, to which thing they are going, from which entity they are going to which data store, from which data store they are going to which. This thing you have to see. This makes the people makes error on this also, that you are just showing the data flow, but you are not giving the arrow. That is from which to which it's going, it's not shown. So this thing you have to take care of. This is also what happens when you are committing any error in DFT. Okay. Now one more thing is that is you have to take care always that whenever you are making a particular, suppose whenever you are showing a data store, suppose this is my data store. Okay, any storage. Like in a previous case, what it was a board. Okay, you will see that from a particular bubble, okay, this data store, this can happen, or this can happen. These things can happen from data store to a bubble to a data store. But these things can happen, but a data store to a data store can never happen. Okay, a data storage, from a data storage to a data storage, it can never have any kind of data flow. Never have. Since why we are not having that one? This is my function. If I will do any function, in previous case also we have seen that in sometimes when we were playing the move, that was shown in our board. That was our data storage. That is playing the move, the function to the storage. But when the storage was we were showing the display in the board, that was from the storage to the board. But it can never happen that the data cannot flow from a storage to storage. How this will happen? This cannot happen. Since you have to have some function which you will be having the data from a function to a particular storage, or a storage to a function. But it can never happen from a data storage to data storage. Some data is going on. This flow can never happen. Okay, so this thing you have to keep in mind, that from a storage to storage, no data, any data can never flow. That, so this is also a mistake which is being committed while making a DFT. And the last one that we have to see, that is we have always to show data storage to data storage, no data flow. Okay, here no data flow. Then, and last one is what? We have to see all the SRS documents, all the functions that is mentioned in our SRS documents. All the functions mentioned in your SRS document should always be shown in your DFT. Since your DFT is the reflection of what requirements you have in your software, you are getting the requirements from the customer, and from those requirements you are going to make develop the design. So while making the design, okay, the main basic design, you have to keep all the requirements, whatever things your customer has given to you. Then you can make a best and a quality software. Then, so you have to keep in your mind whatever things my customer has given me to implement in my software, those requirements I have always to put in my particular DFT. Then only I will give a good design, and which will give a particular accurate software which will be needed by the customer. That so these things, these errors, basically what happens, these errors are being made while making a DFD. So always take care while developing a DFD, always you have to take care of these particular points, right? Now what the basic shortcomings of a DFD? What are the shortcomings? Everything is correct. DFD is helping us in a very huge way, but some shortcomings are there which we will discuss now. Okay, what are the shortcomings of this DFD? Functions performed by bubble should be precise and specific. That is, whenever you are making a DFD, like I was making here, human player and the software, tic-tac-toe software. Okay, so what I was seeing there, functions performed by my particular bubble is very precise and specific. Why specific? Here what? My particular software is going to play the game of tic-tac-toe. That's all. That is very precise. It's not huge. It's not very descriptive. No. It is very precise. My software is going to play a tic-tac-toe game. Second thing, very specific. To the point answer. To the point thing you have to show there. Again what we were showing. Validating move or displaying board or what? Playing move or showing the result. So these also you can see, these were our next level, these were the functions, right? So here also you can see the functions are very precise. Validating the move means it is just validating the move. Displaying the board, playing move, showing the result. So what is happening there? We can see that what they are doing, basically they are just showing us a specific one, precise and specific one. Very precise. This thing, this function is showing me the, displaying me the board. Not very descriptive. You can easily understand from the name of your function, you can easily understand what function is going to be done by your particular function, particular bubble. So you have to make it very precise and very specific. Not a descriptive one. You are going and writing many things in your bubble. No. Very precise. What function is going to be done by your particular bubble. Very precise and very specific. To the point answer. Okay. So this thing is playing move, showing result. Then very specific and very precise. So this is the main thing. This is the advantage also. This is the advantage also, since you are showing a very specific manner, you are showing your DFD. But the shortcoming is there, that is, in that thing you have to show your basic data. You cannot use more words. You cannot express by more words. No. You have to show this thing in a very precise manner, very specific manner. So you have to have that art to make it a very specific manner. Okay. Now next thing, no control aspect is not shown here. Since it's not a flow chart. Already I have told you it's not a flow chart. So no control structure is not shown here. You cannot from a DFD, you cannot know what is my control, how the control is going on. No. You will only show the data. Only the data is shown. This will, what the thing is going on, this is showing a, I am doing a move. This is displaying my move. But how this is happening, these things are not shown. The control is not shown here. So you have, it is the shortcoming also. What the thing are going on, that is not shown. Only the basic data flow is shown in your DFD. So this is the shortcoming. You cannot know about more details, you are not knowing there. It is only for a basic idea only, but not for a descriptive manner. For a descriptive thing, you have to follow other charts, or we will study about more charts. But this thing is basically showing you the main structure, main function. Okay, huge description is not been shown here. So this is a shortcoming. Now decomposition has been done. Third one is what? Decomposition. What is decomposition? This was my level 0. Now my level 1. Suppose it is also not sufficient, then you have to again construct level 2, then level 3. So by this what? Until and unless you are able to describe all the functions neatly and accurately, you have to decompose your DFD. This is a huge shortcoming. Since from one particular this DFD you can only know the function, what is happening here. But to describe your DFD, maybe it will take 3 to 4 levels also. To describe your DFD, to describe wholly, you have to go through other levels also. So this is a shortcoming. From one DFD or two DFD, you are not going to give the description of your whole software. Obviously, you need 2-3. So ultimate level, whenever you are not up, until and unless you are not reaching your ultimate level, you are going on decomposing your DFD level by level. So this is a shortcoming. It is huge time taking also for your designing phase. Since you have to, in rapid action development model, other models, you have to have the project done in a specific time also. So you have to take care of that. So it's a shortcoming. And how to decompose is not shown. You are showing how we are just showing this decomposition, that is my, from this software or this function, I am decomposing this function to this. But how I am decomposing, why I am choosing these sub functions, that I am not showing. It's not a descriptive manner. It is just a basic idea of your DFD. How you are going to decompose, how you are going to show, that is being shown here. But how you are decomposing, the whole data is not provided. So this is also a shortcoming of your DFD. The whole description is not given. It's not a descriptive data. It's only basically a definition of your data. I have already told you, data dictionary is also data about your data, definition about your data, but not description about your data. Okay, so this is the shortcoming. You are not getting the whole description. You are just getting an idea, basic idea you are easily getting from this one. But description you are not getting. How these are decomposing, how these functions are going on, how this data is flowing. These things are not coming. What data is flowing, that you are getting. That thing you are getting from it. But how this data is flowing, you are not getting from there. Then now all functions you have to show. That is your main shortcoming. This is the advantage also, that from a particular DFD, if you are taking a data dictionary, you are getting all the functions you are getting, or all functions which you are using in your particular software, everything is being shown in your DFD correctly, level by level. But what is happening, that is also your shortcoming is also there. That is, you have to show all the functions of your particular software. It's very time taking. So as well as for your designing phase, it will be a lengthy process also. So this is also a shortcoming of your DFD. So always remember, while making a DFD, you have to see that you have to start from the context diagram and end until you are reaching the ultimate level. But it is a very you can have a very beneficial way for making this DFD. While you are constructing a data dictionary, you can have a basic idea, very nicely and accurately you can give the idea what your software is going to do, what the functions are included in your software. But also it is time taking, as well as it is a huge and lengthy process. Figure by figure you will have to construct, then you can give a data about your particular software. Then so this was all which was included in data dictionary as well as DFD. Now in next class we will again have some topic related to these designing tools only. Then if you have any kind of queries, you can ask me in your comment section, and if you want to give me any suggestions, anything, then you can write to the comment section. If you like my videos, then please give me a like and kindly subscribe my channel so that I can share more subjects related to our technical education. Thank you and take care.